All right, so we're thinking now about kind of classifications of numbers, and so when we oftentimes think of a number, we just think of a counting number. Essentially, we think of sort of numbers that we can count with on our fingers. We think of our place value system, perhaps, especially within our base 10 system. Um, and if you kind of like zone out or zoom out a little bit, you can see that there are sort of these specific ways that we can talk about and classify and organize all of our numbers in our number system. So, at the very tip top of the umbrella is are all of the numbers, right? And so from there are two different places you can go, right? You can either become a real number, or you can become an imaginary number. So when we think of an imaginary number, we're not going to get too much into this, but it's essentially it's like the square root of a negative number, right? And so real numbers are basically everything else, right? They are numbers that can be represented on a number line, essentially. And there are tons and tons and tons and tons of them. And so when there is something still so big, right, we have all numbers and we've only classified them into two groups, there's still a lot of other ways we can think about them. So an imaginary number is simply that, it's just itself. Whereas real numbers have all these other ways that we talk about them. So when you become a real number, you can now go one of two ways again. So you can become what we call irrational, or you can become what we call rational. So we're going to kind of talk more about this in a minute, but essentially a rational number is any number that basically it can be a decimal, it can be a fraction, it can be a whole number, it can be positive, it can be negative. It also always it can't be non-repeating as a decimal, so it has to end. It has to, whereas a rational number can be a decimal that just never ends and never has a pattern to it. It never repeats. We'll talk more about what that kind of means more specifically momentarily. When you become a rational number, you can then become different types of things, right? You can become a fraction, or you can become an integer. So if you become a fraction, right, we're more familiar with fractions. You can be a proper fraction, meaning your numerator's smaller than your denominator, or you can become improper, right, where you're top heavy. Your numerator is bigger than the denominator. If you become an integer, and we've been kind of exploring this idea of an integer as a whole number, including it could be zero, positive, or negative, right? So there's two routes to go. And if you happen to become a positive integer or a whole number, then you can include zero, and you can also kind of, there's this grouping that we call natural numbers. We can kind of also think of them like counting numbers. So if we start kind of at the top of our hierarchy, right, we've entered the land of rational numbers. You can kind of see this cool kind of, this is another kind of graphic organizer, a way of kind of thinking about and organizing and incorporating these numbers together. So everything inside of here is a rational number, right? So a rational number is any number that can be written as a fraction, right? And there's some solid examples here. You'll notice that it can also be zero. An integer, right, is a specific type of rational number, and it has to be a whole number, and it can be either positive or negative. It can also include zero. A whole number, right, is any whole number in the positive realm, could also be zero. And then we have these things that we call natural or counting numbers, and those are any whole number positive, but it's not including zero. Outside here, right, the opposite of sort of a rational number is this idea of an irrational number. So those are kind of in their own bubble over here.